અમારા વધુ લેક્ચર્સ જોવા માટે www.ezilearn.ooo વેબસાઇટ પર ન્યૂ સ્ટુડન્ટ તરીકે રજિસ્ટ્રેશન કરો. અમારા વધુ લેક્ચર્સ જોવા માટે www.ezilearn.ooo વેબસાઇટ પર ન્યૂ સ્ટુડન્ટ તરીકે રજિસ્ટ્રેશન કરો.
Hello everyone, how are you? I hope you all are fine and welcome to this world of education, to this golden platform of EziEducation. Myself Abhijit, friends. I have been your Maths and Science faculty for quite some time and today's class is the class of Science and Technology. Friends, today's episode is an important one because I'm going to teach you a famous topic in 10th standard. It's lens formula, friends. Yes, in the episodes, in the previous one, I have taught you mirror formula in the same way. Based on the same concept, we have lens formula as well. What is the difference between mirror formula and lens formula? In mirror formula, we are dealing with reflection, and in lens formula, we are not dealing with reflection, we are dealing with refraction. And it has got some new things in it, some new figures, a new concept. Let us start today's episode. This is the 6th episode which I am delivering in front of you for this chapter. Chapter number 2, light, reflection and refraction. Yes friends, 6th one. I have completed 5 complete episodes. Here is the 6th one and starts an important topic, lens formula. First of all, the question arises in your mind, sir, what is lens formula? Friends, lens formula is a formula related to lens. Whenever a lens, in our day-to-day life, the microscope, the telescope, whichever thing, whichever optical instrument, the camera, whichever optical instrument we use is having a lens in it. You have microscope with you, it's using the lens. You have the cameras, they are using the lens. You have the telescope, again lens comes into act in those all instruments. So lens formula is a formula giving the relation between object distance, image distance and the focal length. So that is the definition of lens formula. If anyone asks you what is the definition of lens formula, the definition is very much simple. Lens formula is a relation between object distance, image distance and focal length. So let us write down the definition. The formula giving the relation between object distance, image distance and the focal length. Is known as the lens formula. So just mug it up. The formula giving the relation between object distance, image distance and the focal length is known as lens formula. Now a question arises, can you show us what is object distance? Can you show us what is image distance? And can you show us what is focal length? You have taught us that the formula giving the relation between image distance, object distance and focal length is known as lens formula. Clear once and for all. But where is object distance, what is image distance and what is focal length? I'll depict all those things with a clear figure. So I'm going to draw one figure depicting the whole story of lens formula. Friends, let us select axis. Let this be the principal axis. I've taught you all the things related to a lens. So don't you ever ask, so what are the focal length? Actually, we all know, we have gone through the formulas in the last episode. That was the 5th. The ending portion, I have concluded all the definitions, starting from radius of curvature, center of curvature, focal length and all those things. Here, I'll take one lens. This is a convex lens for us, and we have to take one object for the study purpose. Let us take object as AB. This is the lens, friends. This is the object AB, which we are going to use to find out our answer. You exactly know the center of the lens. Name it as O, origin, O, and AB is the object placed on the left hand side of the lens, because the Cartesian sign convention will come into play in this theory also, because the whole chapter is whirling around Cartesian sign convention, which I have taught you in the very second episode of this chapter, where I taught you the rules of finding out mathematical relations. Here the object has to be on the left hand side of the lens, so it is on the left hand side of the lens. Now equivalent to AB, let the height of AB is h. Let the height of AB is h, and equivalent to AB, let us take one more point D. So OD is equals to AB. OD is equals to AB. Just mark it down, just keep it in records, it will be useful in the later part of the theory. Here we will learn now refraction as, this is AB. You know, all the parallel rays after passing through the lens bend, they meet at one point. They meet at one point in the principal axis. This point is known as focus. This point is known as focus, F. Is it clear? This is a ray parallel to the principal axis, passing through the lens, meeting the principal axis at one point. That one point is known as focus. Let us take, for the sake of study, one other point. Passes through the origin, here it is, and the point where it meets will be the image A dash, B dash. A dash, B dash is the image. This whole figure depicts the whole scenario. What is refraction? Where is the object? Where is the image? Let me make it a quick revision for you. AB is the object, A dash, B dash is the image. All the distances are measured from O. So from O, if you measure B, this will be OB as the object distance U, but since it is in opposite direction, it will be minus U. It will be minus U because it's going against the incident direction. Now OB dash is plus V, and OF is plus F. So these three things you need to feed in your mind. OB is the object distance. So let me write OB is the object distance, and it's against the incident direction. It will be negative as per the Cartesian sign convention. OB dash is equals to the image distance. It will be plus V as per the Cartesian sign convention. OF is the focal length plus F. That's it. Object distance, image distance, and focal length. That's it. One thing you should remember, that AB is the height of the object. Equal to AB is OD. Now this was the pictorial explanation, the diagrammatic explanation is over. Now your target is, sir, how to achieve our final destination, that is the lens formula. As I have told at the very first place, lens formula is a relation between object distance u, image distance v, and the focal length f. A mathematical relation between u, v and f. Object distance, image distance and focal length is the lens formula. But how are we going to attain it is a target for you, and I will give you one shortcut trick. You remember two triangles, two pair of triangle. I tell you the name of the triangle. ABO and A dash B dash O is the first triangle which you need to remember. ABO, A dash B dash O, these both are similar. And ODF, ODF, B dash A dash F. These two sets of triangle you have to remember and you will be sorted out. The answer will be with you. I repeat, the first set of triangle you need to use is ABO, A dash B dash O. I repeat, ABO triangle is similar to A dash B dash O. You get one answer. Next set of triangle ODF, B dash A dash F. That's it. I am going to practicalize whatever I have explained till now. Let us start it. Now, as shown in the figure, an object AB of height h stands on the left hand side of the lens. As shown in the figure, an object AB of height h stands on the left hand side of the lens, on the left hand side of the lens, and from the figure what you get to know is similarity between the two triangles. First set which you are going to use is what I am going to write. Triangle ABO is similar to triangle A dash B dash O. Triangle ABO is similar to triangle A dash B dash O. Now apply the laws of similarity. You know the laws of similarity? Do you? AB upon A dash B dash AB upon A dash B dash is equals to AB upon A dash B dash is equals to OB upon OB dash. I repeat the whole thing once again. First thing which you need to memorize is the similarities of triangle. We have to take two different set of triangles, not two triangles. I am talking about two set. Set means group of triangle. First set is ABO similar to triangle A dash B dash O. Now you know the simple rules of similarities, the mathematical terms, that is the first side upon first side is equals to second side upon second side. The first side of this triangle upon first side of this triangle equal to second side of this triangle upon second side of this triangle. Okay. Now AB upon A dash B dash. What is OB? What is OB dash? So let us come to the figure, friends. I will show you what is OB and what is OB dash. Here it is, the figure. OB is nothing but the object distance which is minus u. Why it has attained a negative value? It's against the incident ray, so its value will be negative as per the Cartesian sign convention. OB is minus u, OB dash is plus v. Image distance and object distance respectively, here they are. OB is minus u, OB dash plus v. This will be saved as a result number 1, and later on in the coming stages we are going to utilize this result. AB upon AB dash, A dash B dash is equals to OB, which has a value of minus U, OB dash, which has a value of plus V. Now what? You say, now what? Next step will be your second group of triangles, second pair of triangle, which was, I tell you, the name you need to learn. Also, from the figure, triangle ODF, similar to triangle B dash A dash F. Triangle ODF is similar to triangle B dash A dash F. Now what you get as your result is again the similarity rule. OD, the first side is OD upon A dash B dash is equals to OF upon FB dash. See, from the figure again you get that triangle ODF is similar to B dash A dash F. So what result you have obtained is the first side OD upon first side A dash B dash is equal to third side. I am not talking about DF, I am talking about OF upon B dash F or FB dash. But you should not forget one thing. You should remember value of OD. What is the value of OD? At the very first place I have shown you OD is equals to AB. Where? Here it is. Come to the figure. You can see OD, the height of OD is equals to height of AB. So isn't OD equal to AB? Yes, it is. You can write in place of OD the value as AB. So I am going to do it. In place of OD, I will write AB upon A dash B dash. Now you need to tell me OF. What is OF? OF is the focal length whose value is F. What about FB dash? Have you ever thought about FB dash? Let us think. Go to the figure. Here it is. FB dash. FB dash. This much value. How can FB dash be obtained? FB dash can be obtained by subtracting OF from OB dash. By subtracting OF from the whole OB dash. The entire OB dash is V. The entire OB dash is V. From that entire OB dash, you subtract F. You end up getting FB dash. So your answer of FB dash is V minus F. What is the answer? V minus F. So I write it down FB dash as V minus F, which concludes one of the important steps for me. Result number 2. Friends, this part which I have written just now is comprising almost 40% of the whole topic, and it's the most important part. 3 steps, but damn important. Let us have a quick recap of what we have done till now. As shown in the figure, object AB of height h stands on the left hand side of the lens. Is standing on the left hand side of the lens. From the figure, the first similarity which we are going to deal with is triangle ABO similar to triangle A dash B dash O. So when I say similar, first side upon first side, here the first side is AB, here the first side is A dash B dash. Here the second side is OB, here the second side is OB dash. OB upon OB dash. And now OB has value of minus U and OB dash has value of plus V. So minus U upon plus V is the result number 1. Next, from the figure, ODF similar to B dash A dash F. ODF similar to B dash A dash F. This result also you need to learn by heart. If I can suggest, you should learn by heart so that you end up doing less mistakes. Unless some people, what they do, they leave it on the sum itself. They leave it on the question itself. It will come by a natural way. Yeah, it can come by a natural way unless you have a clear concept. If you don't have clear concept, at least try to learn the similarity, the similar triangles, the name of the similar triangles. If you learn them, you end up getting full marks. because then you are less exposed to the mistakes. So ODF is similar to B dash A dash F. So OD upon A dash B dash is equals to OF upon FB dash. Now as soon as I tell you OD, you have to remember what I have told you at the first place. OD is equals to AB. So substitute the value of OD as AB, you get AB upon A dash B dash. Now OF is actually F, focal length, and FB dash is equals to V minus F. Now you have to tally, you have to make some conclusions from result 1 and result 2. What is result 1? Tell me friends. Result 1 is AB upon A dash B dash, which has some value minus U upon V. Again I have result 2 whose value is AB upon A dash B dash, whose value is F upon V minus F. So I have AB upon A dash B dash minus U upon V. Again I have AB upon A dash B dash F upon V minus F. So both are important results for us, and now minus U upon V is equals to F upon V minus F. We will equate result 1 and result 2. Please friends, focus over here. I have result 1 consisting of AB upon A dash B dash. I have result 2 consisting of AB upon A dash B dash. What I get at the end is to equal both the answers, and after making both the answers equal from result 1 and 2, what I get? Thus, from result 1 and result 2, minus U upon V is equals to F upon V minus F. This step is what I get at the end of result 1 and result 2. Now simply cross multiply. Come on friends, try to cross multiply it correctly. Minus U into V minus F. Minus U into V minus F is equals to Vf. Minus U into V minus F is equals to Vf. Minus UV, just go for internal multiplication, minus UV, minus into minus plus UF is equals to VF. Minus UV plus UF is equals to VF. Minus UV plus UF is equals to VF. Dividing the whole result by UVF. Dividing by UVF on both sides. Dividing by UVF on both sides, we get minus UV upon UVF plus UF upon UVF is equals to VF upon UVF. Minus UV upon UVF plus UF upon UVF plus is equals to VF upon UVF. Okay, again when you get this result, you take a sort of LCM, if I can say, dividing UVF, which comes out as a LCM if there was any denominator, dividing by UVF on both sides. So both sides getting divided by UVF, it was UV minus UV getting divided by UVF, it was UF getting divided by UVF, it is VF getting divided by UVF. Now you will come across some cancellation, so just check out what will be cancelled. See here UV and UV will be cancelled, U and V, U and V. So what is left out is minus 1 upon F, UF getting cancelled, UF you get plus 1 upon V, and VF cancelled, we get 1 upon U. So this result you get, which is not yet the final answer. Two steps are still remaining. Let us go through this part, this what I have written here. From result 1 and 2, the previous two things, one was AB upon A dash B dash, the other one also was AB upon A dash B dash. Both were result 1 and result 2, both were equal. Making them equal, we end up getting minus U upon V is equals to F upon V minus F. Then go for cross multiplication. So minus U into V minus F is equals to VF. Then go for internal multiplication, minus u into v minus uv minus minus plus uf, minus uv plus uf is equals to vf, minus uv plus uf is equals to vf, dividing by uvf on both sides, dividing by uvf on both the sides. So minus uv upon uvf plus uf upon uvf is equals to vf upon uvf. So uv cancel, minus 1 upon f, uf cancel, plus 1 upon v, vf cancel, 1 upon u. Now just bring it in some useful way, as the definition of length formula tells us that it is a result between object distance, image distance and the focal length. Focal length should come at the last. Here what I am going to do, I am going to move this minus on that side, making it plus, and this one towards here. But I'll write this, I'll copy this, and then I'll bring the conclusion over here. Since minus 1 upon f plus 1 upon v is equals to 1 upon u, what you should do, should bring this towards left hand side and this thing on the right hand side. So 1 upon v minus 1 upon u, 1 upon v minus 1 upon u is equals to 1 upon f. This 1 upon u comes on this side, 1 upon v minus 1 upon u minus 1 upon f goes on to that side, becomes plus 1 upon f. This result, 1 upon v minus 1 upon u is equals to 1 upon f. Length formula. Yes friends, this result is the final destination for us in this episode. We are working for length formula, and this result, 1 upon v minus 1 upon u is equals to 1 upon f. It is indeed a relation between object distance u, image distance v and the focal length f. So finally we have a relation which is between object distance, image distance and focal length. Continue this topic, continuing the length formula, we have one topic connected to it, that is magnification. What is magnification? I will teach you in a short while. Please stay with us, and meanwhile start copying down the notes.